Welcome to Grade 12 Advanced Mathematics, Unit 5, Integration, Topic 5.3 Area. Let's explore the concept together. In this video, we will learn how to compute the area under a curve using summations and limits. Welcome to HasnaSparkVibes. Let's spark our math skills together. Let's begin with the keywords. Please note, we will come across with a beautiful word Riemann sum. Here, we will focus on three levels. First, right endpoint, then left endpoint, and finally midpoint. But please note, if nothing is mentioned and you look for the final area, you can directly enter integral function in the calculator, enter your function, and you should be having your lower limit as a and upper limit as b. With dx in the calculator, you will get your answer directly. But if they mention for right endpoint or left endpoint or midpoint or Riemann sum, you are supposed to follow the procedure. Here, we will highlight the definition with the help of Riemann sum to find the area under the curve. It's nothing but limit n approaching to infinity, sigma I is equal to 1 to n f of ci delta x. Evaluation points using left endpoint, right endpoint and midpoint. For right endpoint, what will be the evaluation? It is nothing but xi. For left endpoint, xi minus 1. What about for midpoint? It's the average of both, which is half of xi minus 1 plus xi. You can remember using the closed interval. This is your left endpoint and xi is your right endpoint. How will you recall your midpoint? That's the average of left and the right. For the increasing function, if you notice the left end, right end and the midpoint, you should mention one important point over here. That is, for right endpoint, in your increasing function, your approximated area will be greater than the actual area. But when you look at your left endpoint, your approximated area is smaller than the actual area. Check with the decreasing function if you are noticing your right endpoint, left endpoint and midpoint. Your comparison between the approximated area and the actual area are: when you check for right endpoint, your approximated area is smaller than the actual area, whereas your left endpoint, your approximated area is more than the actual area. If you notice your evaluation points and how will you apply the Riemann sum for right endpoint, Ci is equal to a plus I delta x. How can you recall? If you look at your I, already we know you'll be concentrating on xi, isn't it? So your evaluation point for right endpoint is a plus I delta x. Whereas left endpoint I minus 1. And you remember your Ci is xi minus 1. So your evaluation point is Ci equal to a plus I minus 1 delta x. And how did you find the midpoint? The average of xi and xi minus 1, isn't it? So if you remember, you can go across with I minus 1 plus I over 2. If you notice how many i's are here, 2i, isn't it? So you get 2i minus 1 over 2. The common denominator, I am splitting it for both the terms. You can cancel 2 and 2 and you are left with I minus half, and that's how your evaluation point, your midpoint is a plus I minus half delta x. In all the cases, your Riemann sum reminds us sigma I equal to 1 to n f of ci delta x. Please recall the formula again and remember at the right time. The last question of this topic. Compute Riemann sum for the given function root x plus 1 on the closed interval 1, 3 for n equal to 10, 50, 100, 500, 1000 and 5000 using left hand point, midpoint and right hand point. Here in this video, I will be doing n equal to 10. Please do practice 50, 100, 500, 1000 and 5000. And you can comment below if you face any confusion. At that point, I will guide you. Now let's start with the solution. You know your A is nothing but 1, that's your first number, and B is 3. So let's find our delta x, which is b minus a over n, and already I decided that I'll move with n equal to 10. So you will get your delta x as 1 over 5. Now let's start with left hand point. As I mentioned in the previous slides, the formula for the point is a plus I minus 1 delta x. Let's substitute a as 1 and delta x as 1 over 5. So you will be receiving I over 5 plus 4 over 5. How? We are simplifying it. I by 5, also the 5 is common for minus 1. So negative 1 over 5. So if you are clubbing the numbers 1 and negative 1 over 5, you would have got plus 4 by 5. I by 5 is clubbed with that. Now let's apply the area formula. We will replace our CI by our new CI, which is I over 5 plus 4 over 5, and your delta x is 1 over 5. So you will replace your x value by your new CI, which is I over 5 plus 4 over 5. As 1 by 5 is common, I took it outside. Let's enter exactly like this in the calculator and you will find it out as 3.38879. Now let's move with the midpoint. Your delta x remains the same because your NAB remains the same. Now let's apply midpoint formula. A plus I minus half delta x. What's your A? Yes, it's 1 and delta x is 1 over 5. So when you replace it and simplify, you will be get your CI as 9 by 10 plus I by 5. How? Your I will be divided by 5 and half will be divided by 5. That's how you got negative 1 by 10. Later, club with 1, you will get 9 over 10 plus I over 5. Now let's find sigma. When you find sigma, replace your Ci with your new Ci, which means you replace your x by your new Ci, that is 9 over 10 plus I over 5. When you substitute in the calculator, you will get your answer as 3.44788. Now let's proceed with the right endpoint. Here also your delta x remains the same. What's the formula for right endpoint? And I want to mention one more thing. When nothing is mentioned, they didn't mention left endpoint, they didn't mention midpoint, they didn't mention right endpoint. But the question is for the writing. So you can do using right endpoint because this is the easiest compared to the other two, which doesn't mean they are difficult, but just compared with all students find right endpoint as comfort zone. So let's continue. A plus I delta x. Substitute a and delta x. You will be receiving it as 1 plus I over 5. Substitute it in the summation and replace your x with your new ci, that is 1 plus I over 5. Enter it in the calculator and you will find your final answer as, this is just for 10. I told we have 50, 100 and some big numbers. So let me show you the table which I mentioned over here using all the listed values for left endpoint, midpoint and right endpoint. You can notice one common thing. All these numbers, they are converging to the common limit which is 3.447, and so the final answer for this question you will get it from the calculator when you enter integral 1 to 3 root x plus 1 dx. The exact area will be 3.4477. That's all with the topic 5.3 area. See you in the next concept. Keep practicing, keep revising. Remember, practice makes perfect. Thank you and bye-bye.